8 to the 3/4 power over 8 to the negative 1/4. Alright, so you have a negative exponent. Kind of talked about this yesterday with the negative exponent, but we had fractions yesterday, right? So you just took the fraction, you flipped it. But if you remember what I said yesterday, you could have just taken it and like flipped it to the bottom, right? It's kind of the same here, except you got a negative exponent on the bottom. So we don't want a negative exponent on the bottom. Well, actually, you could do this two ways. I'm going to show you this way. This is how I would think about it probably. But you could take this and flip it to the top. All right, there's another way you can think about it too. You could just subtract the exponents, couldn't you? That would be one way to do it. Does that make sense? Right, because when you're dividing and you got the same base and you got exponents, you could just subtract the exponents from each other. Okay, but yeah, you could do that. But the problem with that I've encountered with a lot of students is a lot of students would go 3/4 minus 1/4, but it's not, is it? It's 3/4 what? Minus what? Negative 1/4, right? Minus a negative, which will eventually be what? Plus. So 3/4 plus 1/4 is 4/4. 8 to the 4/4, 8 to the first, which is just 8. Correct? All right. You could do it that way. That's perfectly fine. But there's so many times where we take these negative exponents and flip them. I'm just going to stay consistent with that way of doing things. So I could take this, flip it to the top, and that's to the positive 1/4. It'll come out to the same exact thing. Because now what we're doing is now we're multiplying. What's the rule for multiplication when you have the same base? You add the exponents. But now, see, there's the positive 1/4. So you end up doing the same exact thing, don't you? Adding a 1/4, just like you would have here. But again, just in my time teaching this to students, it seems like a lot of people mess that up if they think of subtracting the exponents, especially if they have to subtract a negative. For some reason, a lot of people forget to subtract that negative. All right? So we're going to do this. We're going to multiply them. We're going to add the exponents. So we keep the base the same, we add the exponents. 3/4 plus 1/4 is 4/4, just like we said before. That's 8 to the first, and 8 to the first is just an 8. Alright, hope that helps a little bit. And that method right there is something that we're going to do for the next several problems of flipping it and changing the sign. So it's m to the 5th, m to the negative 3rd over m to the negative 7th. Alright, there's a couple things that you could do here. I'm not going to go through every different possibility of how to solve this problem, okay? I'm just going to go through what I think personally might be the easiest way to do it. Is that alright? So you might get somebody else to teach you and or to tutor you or something like, and they might do things maybe just a little bit different than I'm doing it. Doesn't mean it's wrong, doesn't mean that I'm wrong. It just means there's several different ways you could approach this problem. Okay, I'm not going to sit here and show you every different way. It'd probably confuse you more than anything anyway. What I would do, if I have a fraction like this, I would always simplify the top, simplify the bottom. Alright? So let's do that. Let's do the top. M to the 5th times m to the negative 3rd. The rule, when we multiply these together, we add the exponents. So 5 plus negative 3 is 2. So that's just m squared. And we'll write this m to the negative 7th. That wasn't so hard, was it? Now, it's basically just like this problem up here now, isn't it? So now I could take this. Now again, like I said, there's all kinds of ways you could approach this. You could go ahead and just subtract the exponents if you wanted to. 2 minus negative 7 is 2 plus 7, which is m to the 9th. Or you could think of it this way. Take this negative exponent, flip it to the top. If I flip it to the top, it becomes m to the 7th. Now you can multiply them together. M squared times m to the 7th is m to the 9th. And there it is. Alright. Now again, there's a couple different ways I could have approached this. Several different ways, really. But I think that might be the easiest to understand. Okay? 14. Let's check this one out. Now we got some fractions. Everybody's favorite, right? The rules are the same. The rules are exactly the same. Y to the negative 1/3. And then z to the 7/6. 7 over 6. And that's over x to the negative 1/5. Y to the 7/3. and then z to the negative 5/6. The key to understanding these things is practicing. Okay, I've said that every day this week. Look it up. You got to practice these things. All right, you can't just sit here and watch me do it. You've got to practice it. Find some problems. I gave you a book, right? We don't use a book very often in here, but I did give you a book, and so it's up to you to go find some extra problems to do. Look at your old worksheets. Maybe you hung on to your old worksheets, okay? Practice those again. That's the best place to go, all right? Because if you still have them. So here, let's do it. Again, there's a couple ways I could approach this, but I'm going to do it like this. They're both negative. You could just subtract these fractions, but man, kids just have a hard time with this, and they mess up a lot when they subtract, especially with negatives right here, right? Because it would be negative 4/5 minus negative 1/5. So it would be negative 4/5 plus 1/5, right? And then you get a negative exponent, then you got to change it to a positive exponent. There's quite a few things you have to do if you're going to subtract these exponents. A lot of places where students make mistakes. So I'm trying to think of the way that it's going to give you the least number of mistakes. So I would do this. I would take this one, flip that down to the bottom. Now some people would flip them both. This is negative, so we flip it to the top. This one's negative, so we flip it to the bottom. You could do that if you wanted to, but you don't have to. In one step, watch this. I could take this, flip it to the bottom, and what am I going to get when I flip that to the bottom? What do? I only change one thing. Just change the sign of the exponent, so it's to the 4/5. Now watch. That's all I had to do, because now when I multiply these together, I'm going to get a positive exponent, won't I? Everybody see that? That's why I picked this one to move down here. If I would have picked the x to the negative 5th and put it up here, I would have had negative 4/5 plus 1/5. I'd still have a negative exponent, which wouldn't be horrible, but then we'd have to change it to a positive exponent. This way, just taking this one, flipping it to the bottom, I'll multiply this in the next step, but I've already got a positive exponent, and I'm done in one step, at least with this part of it. I hope that makes sense. Let's do this one. Which one are we going to flip? Well, we're definitely not going to move the positive one up here to make it negative. Let's take the negative one and move it to the bottom because it's negative. Do I move it to the bottom just because it's on top? No. I move it to the bottom because it's got a negative exponent. So that's going to give me y to the positive 1/3, right? So that canceled from here, that canceled from here. And we'll multiply those in the next step. Look at this one right here. This is already a positive exponent, so I don't want to move that one. Let's take the negative exponent and move that one. So I'm going to take this, flip it to the top. If I flip it to the top, I have to change the sign of the exponent. So it's going to be to the positive 5/6, and then it goes away from the bottom. That was the key to this. Right? It's really not a difficult step. It's just seeing a negative exponent, flipping it, right? Changing it to a positive exponent. That's all you had to do. You did it 3 times. Now we're ready to get our final answer right here. Let's look at the top. That canceled, that canceled. What are we going to do here? We're going to multiply these together. Now when I say multiply together, we have a rule. What is the rule when you have the same bases and you have exponents? To add the exponents. Okay, it is a multiplication problem technically, but to find the exponents, you add them together. So 7 plus, it's common denominator, so they rig this thing, make it nice and easy for you. Okay, so it's 7 plus 5 is 12 over 6. What's 12 over 6? It's 2, so it's just z squared. If you want to put that 12 over 6 in like an intermediate step, feel free to do that, but I think you can do that in your head. So that's the top. What about the bottom? Let's do the x's down here. So look what I have. I have x to the 4/5 times x to the negative 1/5. Means we add the exponents together. Keep the base the same, and you add the exponents. 4/5 plus negative 1/5 is 3/5, and so that's just 3/5. So we're done with the x's. Now let's do the y's. We have the same base, add the exponents. Again, they make this nice for you, so you get common denominators already. So it's 1 plus 7 is 8/3, so it's y to the 8/3. And that's it. Everything's positive exponents, and we are finished. And the problem says, now the reason I keep saying, okay, they're all positive exponents, so we're good to go. If you read the instructions, it says write the answers using only positive exponents. Okay, so you can't have negative exponents here. If you have negative exponents, it's going to be wrong because the instructions say use only positive exponents. Make sure you do that. Because I remember some people can't remember who or how many, but I do remember on some occasions some students will write this with a negative exponent. They did the math right, but they flipped it in a different spot. You got a negative exponent. Maybe you had like z to the negative second on the bottom or something like that. And I have to mark it wrong because the instructions say make sure it's in positive exponents. All right, let's do one more of these type. So it's x to the 4/9. So negative or fractional exponents again. Now we have a multiplication, x to the 3/9 minus 4 x to the 2/9. Well, obviously, distributive property. Wouldn't you agree? So let's do the distributive property. All these problems right here are just basically getting you to understand that rule of that product rule is what we call it. Okay, when your product rule for exponents. When we multiply bases together, the same bases together, and we have exponents. That's when you apply this rule. So you keep the base the same and you add the exponents. 4/9 plus 3/9. 4 plus 3 is 7/9. It's a basic Algebra 1 rule that you learn way, way back in algebra. And you hit it a lot in Algebra 2, I'm sure. And we've hit it a lot in here. So here we go. Let's do the next one. Minus, we multiply together. Now that's a 1 out in front. 1 times 4 is 4. Don't forget that 4. Now let's multiply the x's. I've got x times x, so that's, you keep the base the same and you add the exponents. 4/9 plus 2/9. Well, what's 4/9 plus 2/9? 6/9, isn't it? But are you going to keep it 6/9? No, because you always have to reduce your fractions. What does 6/9 reduce to? 2/3, that's right, because 3 goes into both of those. So it's going to be x to the 2/3. That's all you can do with that. These are different exponents. You can't add them together. They're different terms. So you are finished. That's 15. All right, now we go from fractional exponents to square roots, which is also, you also could consider as a fractional exponent, to tell you the truth. Let's do this. It says simplify each radical expression. All right, this is 16. So it's the square root of 150, and you have to simplify that. That doesn't mean put it into a calculator and get a decimal answer. That will be absolutely wrong if you do that. So what you have to do is you got to figure out, is there anything that I can take the square root of that multiplied together is going to equal 150? So let's break down 150. I'll tell you what, let's kind of go off to the side. 150, well, it ends in a 0, so what's the most obvious thing that divides into 150? 10 does, okay? So 15 times 10. Let's keep breaking it down. Now it's pretty easy to break down. 15 is 3 times 5. 10 is 2 times 5. Okay? So that's all I did. I took 150, broke it down into its prime numbers. Let's put it inside of this square root now. I always like to put the smaller ones first, put them in order. It just makes it look a little nicer. So I've got a 2, I've got a 3, and I got a couple 5s. Everybody see that? Now let's take a look inside here. Can I take the square root of anything in here? Well, this is just a 2 by itself. Can I take the square root of 2 and come out to an even number? No. What about the square root of 3? Does that come out to a nice even whole number? No. What about this, though? I have a 5 times 5. That's the square root of 25. What's the square root of 25? It's just a plain old whole number 5, isn't it? So that does come out to a nice whole number. So the square root of 25 is 5. So I'm done with that, right? It comes from here and it goes outside of the square root. And what am I left with inside of here? 2 times 3 is 6, and I'm done. So that's what I would do first. I would break this thing down into its primes, especially if it's a bigger number. Okay? If it's a larger number like this, definitely break it down into its primes. Okay, put it in here in order. See if you have any pairs, right? See if any pairs of numbers are there, because that means it's 5 squared. And the square root of 5 squared is just a 5. Plain old 5 goes out in front of the square root. You can't take the square root of either one of those, so you just multiply them together, put them under a square root, and you're good to go. All right. 17. Oh my, look at this ugly thing. 4 times the square root of 5, not square root, cube root, plus 3 cube root of 135, cube root of 135, minus the cube root of 40. Well, you're going to have to do what we did up here a couple times down here. All right, but it's cube root instead of square root. But the same principle applies. So what I'm going to do, before I even mess with this stuff, I'm going to figure out what the cube root of 135 is. I want to simplify that thing. Because I can't add these things the way they are. Do any of these look like they're like terms? No, so I can't really add them together. So what I want to do is I want to take this and I want to simplify it and see maybe if it does come out to a like term. 135. So let's write that down. 135. What goes into 135? Well, it ends in a 5, so what obviously goes into that? 5 does, okay? So
5 times 27.
Is it 27? All right, let's just stick it in here. 135 divided by 5, and you're right, it's 27. So
Yes, 125 is 5 times.
Okay, so it's 27 times 5, right? You could just stop right there if you wanted to, but let's say we didn't realize that, because remember, we're taking the cube root this time. Do you see anything in here that you can take the cube root of? 27. Okay, hopefully that's a number that you recognize. If it's not, break it down even further. This is 9 times 3, right? Times 5, and what's 9 break down to? 3 times 3, and then you got this 3, and then you got this 5. It's supposed to be a dot right there. So look, you've got 3 3s, don't you? And when I take the cube root of 3 cubed, it comes out to be a 3. But if you wanted to, hopefully you could have stopped right here and realized that the cube root of 27 is a 3. So let's do that. We'll write this over again, because this can't be broken down any further. You've got a 3 out in front, this 3 out in front. So what's this going to give you again? What's the cube root of 3 cubed?
3.
It's 3. So I have another 3 out here. Do you understand why there's 2 3's here? The first 3 is because of this one. This 3 is because it's the cube root of 27. And then what's left over? Look, what's left over after I take the cube root of that? The 5, isn't it? All right, so I've just got the cube root. Put another 3 right there, cube root of 5. All these 3's came from different places, didn't they? This first 3 came from here. This 3 right here came from the square root of 20, or the cube root of 27, and this little 3 was the cube root 3, right? So all 3 3's are different. Minus, let's do the same thing with 40. Well, let's break down 40. Well, you could go 4 times 10 if you wanted to, but I looked at this and I realized 8 times 5 is 40, and what else? I can take the cube root of 8. What is the cube root of 8? It's 2, that's right. So minus, now you don't have a number out in front, so we'll put the 2 out in front. Everybody see that? Because the cube root of 8, watch this, the cube root of 8 is a 2, and that goes out in front. What are you left with after you take the cube root of 8? The cube root of 5, right? You good so far? Tell you what, instead of writing all that again, what's that 3 times 3 going to give you? It's going to give you 9, isn't it? So let's just put that in there. Now do the things look like they're like terms? Yeah, absolutely. But you had to do a little work, though, didn't you? You had to mess around with this one and this one. You had to do a little work to make them look like they're like terms, and now we can add them up. Now this is the easy part, adding them up. They're all like terms, so you just add the coefficients. 4 plus 9 is 13, minus 2 is 11. So it's 11 times the cube root of 5. And that's how you get your answer. Got to practice it, though. It might have looked easy when I did it, but you got to practice doing this stuff right here. And they rigged this, didn't they? They obviously rigged it, right? Because you got a cube, you know, this came out to a cube root, this came out to a cube root, and that was nice of them. All right.
They always rig it.
Yeah, it seems like they do, which is kind of unfortunate because sometimes when you take like science classes and physics and things like that, you get real ugly numbers, and you're so used to your math classes, stuff coming out nice and pretty all the time. Doesn't always happen like that in real life. It rarely happens like that in real life. But we're just trying to learn the basic principles. That's all we're trying to learn. Alright. I'm seeing something already that's a problem, don't you? What is the problem here? Square root in the denominator. Exactly right. Alright, so let's get rid of that first, and then I'm sorry, let's not get rid of the square roots just yet. Let's simplify the square roots before we even try to get rid of the square roots in the denominator. Is that alright?
Yeah.
Okay, so that's already simplified. What about that? Can we simplify that? Yeah, let's take 27. Yep, you got it. Now this is square root this time, okay? So I break it down, so it's not just a 3, is it? Cube root of 27 is 3, but the square root of 27, right? We're doing the square root of 27. It's 9 times 3. What is the square root of 9? It's just a plain old 3. So that goes outside the square root. What's left inside there? Square root of 3. Hopefully at this point you should be able to do that in your head, tell you the truth. So let's rewrite everything. So we'll just rewrite that one. This is going to be 4 over 3 square root of 3 minus, let's do square root of 12. Again, hopefully you should be able to do this in your head, but I'm going to write it down just so there's no question on how to get it. Let's break 12 down. Now you could go 6 times 2, but I'd pick something better than that. What would you pick? I'd pick 4 times 3, wouldn't you? Alright, so the square root of 4 is 2, and then you're left with the square root of 3. See, that square root of 4 came out to be a regular whole number 2, and you're left with the square root of 3 under there. So it's 2 square root of 3. So 2 on the top, and 2 square root of 3 on the bottom. Alright, before we do anything else, I see something I want to do to make things just a little bit easier for us. Do you see it? What about this one right here? Anything you want to do to that real quick and easy? Yeah, simplify it. How do I simplify it? Get rid of the 2's. That's right. This 2 and this 2 cancel out. Now be careful when I say cancel out. Did they just go away and vanish into thin air? No, 2 over 2 is a what? It's a 1, isn't it? Alright, so it's not like there's nothing up there, right? You got to have something up there. So 2 over 2 is a 1, so you got to put a 1 right there. You don't have to do that in that step. I just noticed it. It's not always going to happen in every single problem like that, but I just thought that might make things just a little bit easier. Okay? Let's do this. You could do this a couple ways, but I'm going to do it like this. Let's find a common denominator. And you're like, oh my goodness, that's going to be too hard to find a common denominator. Not really. Look, what do I have? I got a square root of 3, right, in all of those, so I pick one of those, right? I pick one of them, square root of 3, because there's only one here, and one here. Everybody got that? What else do you have on the denominators? You got a 3, don't you? Even though you don't have one in every spot, it doesn't matter. It just has to show up once. Remember doing that thing before? Yeah. So I'll pick a 3. So 3 square root of 3 is our common denominator. Now let's ask ourselves, what did we do to this to get to our denominator? Multiplied it by 3. So you multiply the top by 3. What'd you do to this to get to the denominator? Yeah, multiplied by 1. Technically, you really didn't change it at all, did you? So you don't have to change the top, so you keep that a 4. What'd you do to this to get to the denominator? Multiplied it by 3. So you multiply the top by 3. So 1 times 3 is 3. We're getting there, right? We just found a common denominator, changed our numerators. Now watch what we do here. Well, 3 minus 3 is 0. That's a 4, isn't it? On top, over 3 square root of 3. Can't leave it like this. Now, remember the very first thing I said, we looked at it and we were like, oh, wait a minute, we got a square root in the denominator. But I didn't really try to get rid of that square root at the beginning, did I? I think it's a little bit easier to do what we just did. I think it is. I mean, somebody might say, no, it'd be easier to get rid of it first. But my first instinct was to get rid of the, or to find a common denominator. But now we can get rid of the square root. So how do we get rid of the square root? Multiply by square root of 3 on the top and bottom. Remember this? What allows me to do that? Why can't I just multiply by a square root of 3 over square root of 3?
It equals 1.
It's a 1. That's right. I can multiply anything by 1. All right? It's not going to change the value of it at all. But the reason that I did this, did I just pick square root of 3 out of the blue? Of course not. I picked square root of 3 because when I go square root of 3 times square root of 3, I get what? I get a 3. Square root of 3 times square root of 3 is 3. Now I'm going to do a little bit in one step here. Square root of 3 times square root of 3 is 3, right? 3 times this 3 is 9. Everybody see that? And now I multiply the top. It's just 4 square root of 3. And there you go. That's how you write your answer. Now, I think that's the best way. I'm not going to go through, any other ways to do this, but I think that's probably the best way to approach that problem right there. All right, got a couple more. We'll be done this test. Let's see. Let's go this tan color. What are we on? Number 19, right? So it's m to the negative first minus n to the negative first over mn to the negative first. All right, it says to simplify this thing. Let's see. Do you remember where we start on this? You might think that we would take this and flip it to the bottom, wouldn't you? Because we did that earlier. But what does not allow you to do that? That subtraction right there, right? Okay. If this was being multiplied, if they were being multiplied times each other, absolutely you could take this and flip it to the bottom. But since you have a subtraction in between, or if it was a plus, right? You could be the same thing with if it was a plus. So you have a plus or a minus in between these two. You can't just take this and flip it to the bottom. So what you have to do, remember we talked about this? You have to work with that as if it was just sitting there by itself. Okay, pretend nothing else was there. Pretend it was just m to the negative first. How would you simplify m to the negative first? Right, it'd be 1 over m, wouldn't it? Does that make sense? That's the key to this. A lot of people, even after I explain this, try to take this and flip it to the bottom. But you can't do it if you got a minus or a plus in between here. Alright, so now let's think the same thing for this. So we got a minus, and then n to the negative first. Same exact thing, right? Except it's an n. Right with me so far? Over. And then we're going to do the same thing with this. See this thing right here? Pretend that was there by itself and there was nothing else there whatsoever. Then what would you do with this? You put 1 over mn. That's the key step right there. That's really, I mean, all the steps are important, obviously, but I think that's the real big key step to get you on the road to getting this problem right. Everybody with me? Just take that, got rid of the exponent, made it 1 over m, got rid of the exponent, got rid of the negative exponent right there. Now I don't have any more negative exponents, but I do have to do a couple things, don't I? What do you think? Where do you think the next thing I'm going to look at? That's it. Find a common denominator. You got it. So I'm going to add those two fractions together. Forget this division. Forget this thing on the bottom. For right now, forget it. Let's just worry about adding those two fractions together. All right? So let's do that. Now, when I said forget about it, it doesn't mean don't write it down. I'm still going to write this down, but I'm not messing with it just yet. Let's just mess with this stuff. I got to find a common denominator. Well, it's really not that bad. I've got an m and I got an n. So what's my common denominator going to be? mn. Very good. Ask yourself, what'd you do to this m to get to mn? Multiplied it by n, didn't you? All right, so that's going to be 1 times n, which is n. What'd you do to this n to get to mn? You multiplied it by m. So that's going to be an m. Put the sign in between. So what did I do right here? All I did was just add those two fractions, or subtracted those two fractions from each other. All right, found a common denominator, figure out what my numerator is going to be. Now I'm good to go. Now, it's basically one more step here. This is my numerator, correct? And this is my denominator. What's that line in the middle doing? It's dividing, right? It's a division problem. We talked about this, I think it was yesterday, didn't we? We don't really divide fractions. We never really divide fractions. We always take a division of a fraction and turn it into a what? In a multiplication. So we keep the top the same. And we multiply by the, what's the word? Reciprocal. So that means you have an mn over 1. And now it's really simple, isn't it? Look what happens. Now this is being multiplied by this, isn't it? Alright, so I'm allowed to cancel stuff out now. So this mn will cancel with this mn, and what are we left with? N minus m. And there you go. Took a few steps. Make sure you do the steps in the right order. Practice it. That's all I got to say about that. Any questions? All right, you can ask questions at any point. But if you don't ask a question, I'll keep on rolling. All right, here we go. Number 20. The last one. 3 over 5 minus the square root of 2. All right, what about this thing? Well, it's kind of like the other problem where you can't have a square root in the denominator, but it's a little bit different. Do you see the difference between this? Yeah. What is the difference? No pun intended. Okay, subtraction, right? You got a subtraction right there. And there is a little method that we learned to get rid of this. If all I did was just multiply by square root of 2, would that get rid of the square root of 2? No, because I'd have to distribute it by this whole thing, and I'd get 5 square root of 2, and I'd still have a square root of 2 on the bottom, so I didn't do any good. But we have to multiply by a, what's the big fancy word? Very good, conjugate, not reciprocal, by the conjugate, And what is the conjugate? 5 plus the square root of 2, yeah. I mean, if you don't remember the word conjugate, it's not really that big of a deal. Okay, it's just nice to be able to, speak the same language here. But if you don't remember the word, at least remember what to do. All right, just change the sign in the middle. Why do we do that? Because it's kind of like a difference of two squares, right? So the outside and inside will add up to 0, and we'll get rid of our square root. Now, I can't just do that to the bottom. I also have to do that to the top. And again, we've answered this question already. Let's answer it one more time. What allows me to do that? What allows me to multiply by this stuff in blue right here? It's just a 1, isn't it? Okay, so make sure that you understand why you can do that. I think it's important to understand. So let's go ahead and do the bottom first. Doesn't matter, which one you do first, but I'd like to do the bottom first. Now, it's kind of like a difference of two squares where I don't have to worry about the outside and inside. All I got to do is multiply the first and the last. So let's multiply the first together. That gives me 25, and let's multiply the last together. Minus positive gives you a minus, correct? Square root of 2 times square root of 2, we've done this a couple times already today, is just a 2. We'll do that in the next step, okay? Now let's multiply the top. This 3 is being multiplied by this whole parentheses right here. That's why I put it in parentheses, exactly right. So we distribute it through. So it's 15 plus 3 square root of 2. And we're almost done. So let's rewrite it. 15 plus 3 square root of 2 over what? 23. And that's it. Nothing cancels, right? Nothing simplifies here. And then we're finished. And that's all there is to it. Well, I thought we might be able to get to a few from the other tests, but looks like we're running out of time. Yes? No, you can't. They're not like terms, because this 3 is not a 3 sitting there by itself. This 3 is next to the square root of 2, so this is your term right here. Okay, so this has a square root of 2, and this doesn't. So you cannot add those together. Good question, though. Anything else on what we've done? All right. I hope tonight, maybe by tomorrow sometime. You probably wouldn't look at it tonight anyway. It'd be my guess. But I'm going to try my best to put that other test, that 2, what is it? 2-1, 2-3, and 2-4. Is that what it is? Okay, it's because we skipped 2-2. So this test right here, I'm going to do from scratch. Okay? I'm going to just teach it to myself, basically, right, to the computer. But I'll put it on YouTube, so you can do that. Study the other ones first, though. Give me some time to put this up. But I'll try to do that sometime tonight. All right, so hopefully, cross my fingers. Don't hold me to it, but hopefully I'll have this up tonight and you can look at it. Everybody good? All right, enjoy your weekend. Study, though. All right, study for your midterms.